Good afternoon, everyone. So today we are going to discuss 11th class Mains and Advanced Full Course Test 3. So first 14 questions are single answer MCQ and the last 6 questions are assertion reason type. So without further ado, let's begin with the first question. Now he says let tangent and normal to this conic at P 5, 6 cut x-axis at A and B respectively. Then area of triangle ACB is. Now I'm interested in the area of this triangle, right? I already know the coordinates for this one. So let me try to find the coordinates of A and B, right? Now A is the point of intersection of the tangent with the x-axis. Similarly, point of intersection of normal with x-axis will give you B, right? So if I'm able to write the equation of tangent and normal, my problem will be solved. Now point is given to me. All I need to do is to write the equation of line is to find the slope. Now, the conic is given to me, right? I can find the slope provided I can find the derivative at this point. So, derivative we know how to find. So, x square by 5 minus y square by 9 equal to 1. Now, differentiating with respect to x, so that will give me 2x by 5 minus 2y by 9 into dy by dx, of course, is equal to 0. From here, we can find that dy by dx is nothing but 9x by 5. Now, this is the derivative, but I want the derivative at this point, so at 5, 6. Right? So, that means you know the slope of tangent at this point, and it turns out to be 3 by 2. Now, you know the slope, you know the point 5, 6, you can write the equation of tangent. And the equation of tangent turns out to be 3x minus 2y minus 3 equal to 0. Right? Now, let's come to the equation of normal. Right? I already know the point. All I need to do is find out the slope of the normal. I know the slope of tangent. Now, slope of the normal will be nothing but negative reciprocal of this. So, that is minus 2 by 3. Right? Already know the point 5, 6. I can write the equation of normal. That is 2x plus 3y minus 28 equal to 0. Right? Now, mind it, I wanted the point of intersection with the x-axis. Point of intersection with x-axis, so basically x-intercept. From here, I can get 1, 0. And from here, x-intercept is 14, 0. Right? So, my diagram is somewhat like this. Right? And P is 5, 6. I'm obviously exaggerating the distances, but you can find out. So, P 5, 6. This is 1, 0. This is 14, 0. You need to find the area of the triangle. I think I would say half base into height. Base you know 13. Height we know 6. Find out. The answer turns out to be option A. On to the next one. Now he says the domain of the function is, right? Domain of the function, that means the values of x for which the function is defined. Now I can say there are two quantities, this and this. This should be defined as well as this should be defined. So let me talk about this one now. Numerator is defined for all real x. Denominator is defined for all real x. But I have to make sure that denominator is not equal to 0. So that means 9 minus x square not equal to 0. Or I can say that x should not be equal to plus minus 3. And at the same time, this should be defined. Log of something, right? So that means this quantity should be greater than 0. So, and x cube minus x greater than 0. From here, you can say x into x square minus 1 greater than 0. You can obviously find out, it turns out to be minus 1 to 0. Union 1 to infinity. But mind it, I have to, obviously minus 3 is not even coming into the picture, but 3 I need to neglect. So that is 1 to 3 because I need to remove it. Union 3 to unity. That is why option D is the correct one. Alright, on to the third one. Now he says let observations xi satisfy this condition, as in summation xi minus 3 is 40. And summation xi minus 3 whole square is 1600. Obviously, number of terms 20, number of terms is 20. Now, he says if alpha and beta are mean and variance of observations 2x1 plus 1, 2x2 plus 1, 2x3 plus 1, so on, 2x20 plus 1. Then alpha plus beta is. So, basically, I need to find the mean and variance of these observations. Right? Now, if I look carefully, these observations are nothing but 2xi plus 1. Right? Okay, so let's move back to this one. Now he says summation xi minus 3. Now the thing is, our observation is not xi. Our observation is xi minus 3. But somehow I need to talk about xi. Mind it, if I want to talk about xi minus 3, I am subtracting 3 from each observation. Right? Now, if the mean for xi is x bar, can you tell me what will be the mean for xi minus 3? Each observation has been reduced by 3. That means the mean would be reduced by 1. Logical? Right? So that means if I can find out the mean for this one, which I can easily do that, I can find out x bar. Right? Now, mean for this one is, now I know summation as in sum of all observations divided by number of observations. So 40 divided by 20, that is 2. Right? So here the mean is 2. And this 2 should be equal to x bar minus 3. So x bar I know, that is 5. Cool? Similarly, let me talk about the variance also. For which one? Xi. Right? Now, let us see what is happening. Now, our observation is xi minus 3. Variance. If I subtract 3 from each observation, do you think that will have any effect on the variance? Absolutely not. The variance for xi, if the observation is xi, and if the observation is xi minus 3, the variance remains the same. So, if the variance remains the same, I can find out the variance for this one, xi minus 3. Why? Because this is given to me. So, let me find the variance. So, sigma square, that is summation xi minus 3 whole square divided by number of terms, which is 20, minus summation xi minus 3 divided by 20 whole square. Or basically you can see the mean whole square. Right? From here, obviously, sigma square turns out to be 76. Now, this is the variance for this, but this variance and this variance is the same. So, our sigma square or the variance is 76 for xi. Right? Mind it, I don't have to talk about xi. Actually, I need to talk about 2xi plus 1. Let me see what happens. Right? Now, my observation is not xi, but 2xi plus 1. So, let me move systematically. 2xi. If I am multiplying each observation by 2, what happens to the mean? If the mean over here is x bar, mean over here is 2x bar. Alright? Okay. Now, plus 1, 2xi plus 1. So, obviously, my mean will become 2x bar plus 1. Right? This is the mean that I am talking about. Now, I already know x bar, which is what? 5. So, that means this means 2 into 5 plus 1, which is 11, turns out to be the mean for 2xi plus 1. So, that means this is nothing but alpha. Let me talk about beta, which is the variance for this one. Now, I am not talking about xi, I am talking about 2xi. Right? Suppose here the variance is sigma square. Now, each observation is multiplied by 2. The variance will be multiplied by 2 squares. So, that means the variance will become 2 times. Cool? Now, I want to add one. 2xi plus 1. What happens to the variance? The variance of this and variance of this remains the same because adding and subtraction doesn't affect the variance. So, this remains 4 sigma square. Right? Which is 4 into 76. Which is beta. He says alpha plus beta. So, this plus this. The answer is option C. Alright. On to the next one. Now, he says if numbers greater than 60,000 are randomly formed from the digits 0, 1, 5, 7, 8, 9, basically 6 digits, and repetition of digits is not allowed, then the probability of forming a number divisible by 5 is. First of all, you need to understand the experiment over here. Now, he says you need to consider those numbers which are greater than 60,000 and formed from these digits, and repetition of digits should not be allowed. That is my experiment. Experiment will give you total number of outcomes, right? Or maybe number of elements in the sample space. Now, greater than 60,000, this is a 5-digit number, right? Maximum digits that I can use, that is 6 digits. So, two kind of numbers will be there. 5-digit number, 1, 2, 3, 4, 5. Or the second case may be the 6-digit number, 1, 2, 3, 4, 5, 6. Right? Now, let me talk about the 5-digit number greater than 60,000. Right? Greater than 60,000, that means the number over here should be greater than 6. And here I have three possibilities, either X equals 7 or 8 or 9. So number of ways of filling this, that is 3. Corresponding to this, suppose I have pulled up 7 over here. So that means I have 5 more choices. So 5. Corresponding to this, 4, 3, 2, 1. 3, 2, 2, 1, right? So this is nothing but 120 into 3, that is 360. Right? Let me talk about the number of 6-digit number. Now, any 6-digit number would be greater than 60,000, right? So, no restriction on the first place. No. One restriction, you cannot put in 0. Yes, got it. So, that means I have 5 possibilities. 1, 2, 3, 4, 5. 5 possibilities. Right? Corresponding to this, suppose I have put in 1 over here. So, I have 1, 2, 3, 4, 5. 5 possibilities. Then corresponding to 4, 3, 2, and 1. So, that is 120 into 5, that is 600. So, for the experiment, I have 360 numbers, which are 5-digit numbers, and 600 6-digit numbers. So, in total, I have 960 numbers. This is my experiment. Right? Now, the event. Event is the number should be divisible by 5. That means out of these numbers, I need to only have those numbers divisible by 5. So, let me talk about the 5-digit numbers first. Then we will talk about the 6-digit one. 5-digit number. The number has to be divisible by 5. So that means the unit place. Either it can be 0 or 5. Right? 0 or 5. Two cases need not be, but it's okay. For better clarification. Right? If 0 is coming over here, let me see in how many ways can I fill the first place. Now mind it, the number has to be greater than 60,000. That means either 7 will come, or 8 will come, or 9 will come. 3 possibilities. Right? Then corresponding to this, suppose I have put in 8 over here. 8 and 0 are not there. Right? So 1, 2, 3, 4. 4 possibilities. Then 3, then 2. Cool? That is 72 in number. Right? Now, here the number ending with 5. First place. Again, the number has to be greater than 60,000. So 3 ways. Then 4, then 3, then 2. You can find out. It's actually the same itself. So in total, I'm getting 144 numbers. Right? Let me come on to the 6-digit numbers. Again, the number has to be divisible by 5. So either 0 can come at the unit place, or 5 will come. Right? If 0 is coming at the unit place, first place has no restriction. 0 is not there, so that means 5 possibilities. Then I have 4, then 3, then 2, then 1. So basically 120 numbers. Now, if 5 is coming at the unit place, I have to make sure 0 doesn't come up over here, right? So 5 is not there, 0 is not there. 1, 2, 3, 4. 4 possibilities. Suppose I have put in 1 over here. So 5 and 1 exhausted. So again, I have 4 possibilities. Then 3, 2, 1. So that is 24 into 4, that is 96. Right. In total, I am getting 216 numbers. 144 from here, 216 from here. In total, I am getting 360 numbers. So, number of the favorable outcomes, that is 360. Total, 960. That is why the probability is 360 by 960, which will give you the answer option B. Alright, on to the next one. Now, he says the number of non-empty subsets A of the set, which contains first 100 natural numbers, says that product of elements in A is a multiple of 3. Right? He's talking about number of non-empty subsets. So that means maybe I can have just one element in the subset, or maybe just 2 elements, maybe 3, maybe 4, or maybe I have all the elements, that means 100-member subset. Right? But I have to make sure that the product of elements in all of those subsets is a multiple of 3. Okay. So let me study. Suppose I have one element subset. Right? Now, product of elements should be multiple of 3. So that means maybe I can have subset containing 3, then subset containing 6, and so on, subset containing 99. Right? Okay. Then, if I am having 2 element subsets, right, I have to make sure that the product is a multiple of 3. That means factor of 3 should be there, right? All those numbers which have multiples of 3, at least one of them should be there. So here, the number that I'm selecting, that should be, at least one of them should be a multiple of 3. At least one of them. Now, at least one of them obviously will include exactly 1, and it will also include exactly 2. So I have these two more cases. Now, similarly, if I talk about 3-element subset, again the condition comes that at least one of them has to be a multiple of 3. Now, at least one of them, so that means exactly 1, exactly 2, and exactly 3. Right? All of these cases come, and so on. As we can see that there are numerous cases over here, and it's a little bit difficult to calculate. Now the thing is, at least one of them will not be easier if I can calculate the complementary part. Right? Let me talk about the complementary cases. That means the product of elements is not a multiple of 3. Not a multiple of 3. Right? That means the elements that I have to take in my subset, either it has to be of the form 3k plus 1 or 3k plus 2. If I can subtract all of these subsets from the total numbers, I think my answer will be there. Now, how many total number of non-empty subsets are there? Obviously, that is 2 raised to the power 100 minus 1. Subtracting the empty subsets. Right? From this, I need to subtract all of those subsets which contain either the number this or the number of the form 3k plus 2. Now the question is, how many numbers are there which are either this form or this form in these? Except for 3, 6, 9, so until 99. So basically, except for 33, all of the others are either of the form 3k plus 1 or 3k plus 2. So that means I have 67 numbers. Right? Now, if I can choose like 1, 2, 3, all. Right? In fact, any number I choose from them, I have made sure that the product of elements is not a multiple of 3. So, how many subsets can I form out of these 67 elements? 2 raised to 67. But mind it has to be non-empty, so minus 1. Right? That is why option C is the correct one. On to the next one. Now, he says you need to evaluate this limit. First of all, let me check the form. Definitely 0 by 0 form. So before I proceed further, I need to rectify it. Then sine 2x is here and 2 tangent x is there. 2x is here, x is here. Half angle formulae. That too, half angle formulae may be relating sine and tan. So that reminds me of sine 2 theta, which is nothing but 2 tangent theta divided by 1 plus tangent square theta. Right? Anyways, not a coincidence. 2 tangent x, 2 tangent. Right? So maybe let's change sine 2x to tangent x. So that is 2 tangent x. I will take 2 tangent x common anyways, which I'm left with 1 divided by 1 plus tangent square x minus 2. No, minus 1. Divide by x into 1 minus cos 4x. Now I know what I have to do over here. Of course, 1 minus cos 4x, I will try to write it as 2 sine square 2x. Right? Half angle. Alright, cool. Now from here, if I simplify it, so 1 minus 1 cancels. So in the numerator, I will get minus 2 tangent cube x divided by 1 plus tangent square x. Then I have x over here. Then I have 2 sine square 2x. Right? 2 and 2 cancel. And minus, I can take it common out. So limit of x approaches 0 of this quantity. Don't forget the minus sign. Right? Now tangent cube x. So obviously in the denominator, I should ideally have x cube. Right? So divide numerator and denominator by x. Right? Obviously when you separate it out, blah blah blah, the limit over here turns out to be 1. Right? 1x gets cancelled, so here I have x square. Perfect. Now sine square 2x and I have x square. Obviously this should become limit sine 2x divided by 2x whole square. Right? So that means ideally I should have 4 over here and then 4 over here. Right? Okay. That means this limit turns out to be 1. Also, this is in the, okay, this is 1 by 4. So this is, because this actually turns out over here, so that is minus 1 by 4. Now, you will be talking about this one. Of course, as x approaches 0, tangent x approaches 0, tangent square x approaches 0, and 1 plus will approach 1. Right? This limit I already know. This I found out to be 1, and this turns out to be 1 again. That means whatever the left arrow factor is there, that is minus 1 by 4. Hence, option B. Alright, on to the next one. Now he says sum of series to 20 terms is. Now, first of all, let me recognize the series. Definitely not an AP, not a GB. In fact, if I look at the options, clearly I can see the answer is 1 minus something, difference of 2 terms. That just reminds me of one little thing. That is called telescopic sum. Right? That means in order to find the sum of this series, I need to write the general term. Right? General term. So as I can see that in each term, I have product of two quantities. So let me write the first quantity. Right? And the numerator of the first quantity. So 9, 13, 17. Now, that is definitely a AP. So that means in the general term, I can write that as 4R plus 5. I can write the R term of an AP, not a big deal, divided by. Now, in here I have two products of two quantities, 1 into 2, 2 into 3, 3 into 4. So that means 1, 2, 3. So R into then 2, 3, 4. So that is R plus 1 into 1 by. So I can see 5 raised by something. So 5 raised by what? 1, 2, 3. So R. Right? So this is my general term. Now the thing is, I need to add up this one. I need to utilize telescopic sum. Now for telescopic sum to happen, I need two things. Consecutiveness and difference. Right? Obviously difference needs to be created in the numerator. Right? Numerator. And obviously I will not be taking the random factors. It has to come from somewhere over here. So mind that here we have 4R plus 5 plus 5. 1. So that means this factor may be multiplied by 5. So maybe multiplied by 5. So this is nothing but 5R plus 5. And then if I subtract R, look, I get 4R plus 5. Not a coincidence. So I can write 4R plus 5 as 5 into R plus 1 minus R. Right? So R into R plus 1 into 5 raised by R. Now let me separate it out because minus is there. Right? So this divided by this minus this divided by this. So 5. Now R plus 1 cancel. In fact, 1 5 I will cancel. So I will get 1 by R into 5 raised by R minus 1 minus. Now R will get cancelled. I will get R plus 1 into 5 raised by R. Look, R plus 1 consecutive. R minus 1 R consecutive. Telescopic sum is ready. Now just put in the value. First you will put. So you will get 1 minus. Obviously you will do that. 1 divided. Put R equal to 1. So 1 into 5 raised by 0. 1 divided by 1 plus 1 2. 2 into 5 raised by 1. One thing. One more. You will write it. You can see that the terms will get cancelled out like this. So first term from here and last term from here will be the answer. That is why option D is the correct one. Alright, on to the next one. Now he says tangent at 1, 9 to the curve touches the circle this, then write the value of C. Right? Now tangent at this. Now I can see that this point lies on the curve. Right? If I'm able to write the equation of tangent itself, then I'll proceed further. Now point is given to me. The other thing I need to find to write the equation of tangent, that is slope. Slope of the tangent will be found out with the help of the derivative. I can find the derivative of this function. 2x equal to dy by dx. How nice. Alright, now obviously at the point 1, 9. Right? So slope of the tangent turns out to be 2. I know the point, I know the slope. The equation of tangent is 2x minus y plus 7 equal to 0. Right? Now it says that this tangent touches the circle. Right? Now I know what happens when the tangent touches the circle. A line touches the circle basically. Right? The distance of the line from the center, that is equal to radius. Since it is a circle, I'll be using this one because it is much easier to use. Right? So distance of, this is the line obviously. So 2x minus y plus 7 equal to 0. Now I want the center. Center minus 8, I can see it. Right? Equal to the radius. Obviously this is of the form x square plus y square plus 2gx plus 2fy plus g plus c in fact plus c. So radius can be written as square root of g square plus f square minus c. Right? G is obviously minus 8 minus g is 8, f is 8, c is in fact this one. So radius turns out to be square root of 128 minus Now, distance of this line from the point, I know how to find that out. So, mod of 2 into minus 8 minus y is minus 8 plus 7 whole divided by this square plus this square, obviously square root, so root 5 is equal to radius square root of 128 minus 3. Now, this is the equation. You can easily solve it. Answer will turn out to be option A. Alright, on to the next one. Now, it says the value of this expression. Right. Now, first of all, I can see cos A, cos B term. So, obviously, I will multiply this term by 2 and divide by 2. Right. This I know what to do. In fact, I have the squared quantity over here. Squared terms, I'm not a big fan because I don't know the formula. So, I would want to reduce the power of this one. Right. So, cos squared 20 obviously can be written as 1 plus cos 40 divided by 2. Right. Half-angle formula I am using because I remember that cos 2 theta is equal to 2 cos square theta minus 1. Re-establish it and you'll get that. From here, obviously 2 multiplies, so you have 2 divides. So 2 into cos 10 into cos 70 minus root 3. Again, I don't want the squared quantity. Reduce the power. So I can write this as 1 plus cos 70 by 2. Also, our decision to turn everything to cos is because of this. Right? Let's see what happens. Otherwise, cos and sine, they are easily interchanged. Not a big deal. Right? First of all, I'll do this. So, minus 1 by 2 as it is. So, 2 cos A cos B is cos of A plus B plus cos of A minus B. So, cos of 80 plus cos of minus 60, but that is 60 itself. Right? Then, from here, I'll write minus root 3 by 2 minus root 3 by 2 into cos 70. Obviously, degrees. And here, 1 by 2 plus cos 40 and 1 by 2 over here. Right? So, 1 by 2 minus root 3 by 2, careful. Also, cos 60, I know the value for this one. So, that is 1 by 2. So, if I multiply, so let me have my constant terms at one side. So, 1 by 2. Then, minus 1 by 2 into 1 by 2. So, minus 1 by 4. And then, minus root 3 by 2. Don't forget that. Plus 1 by 2 into cos 40. Minus 1 by 2 into cos 80 minus root 3 by 2 into cos 70. Right? Now it's very obvious where will I take common from. Yeah? Right? So let me take 1 by 2 common. I'm left with this. Now again, cos A minus cos B, that is 1 by 2 into minus 2 sin A sin B. Sin of A plus B, you know, right? Minus 2 into sin of A plus B by 2, so that is 60 degree into A minus B by 2, so minus 40. Now sign is there, so careful, so I need to accommodate minus sign, so here it will go plus 40 by 2, so that is 20 degree, right? Okay, minus root 3 by 2 into cos 70 as it is, and this 1 by 2 minus 1 by 4, so 1 by 4 minus root 3 by 2. Okay, now let's see what happens. Sin 60 I already know, that is root 3 by 2. This gets cancelled. So basically root 3 by 2 into sin 20 minus root 3 by 2 cos 70. Sin cos. Different trigonometric function. Change one to another. So maybe I'll change sin to cos. So this is cos 70. Same. Cancel. Answer is 1 by 4 minus root 3 by 2, or we can say answer turns out to be option. Alright, on to the next question. Now he says number of functions from this set to this set. Says that this condition is satisfied. Right? Now function, I know that each element should be uniquely associated with element over here. Right? So 1 should be associated to 3, 4 and 4. I cannot say 4 on so on because 4 elements are there. Now this condition needs to be satisfied. Right? So let me just make the cases. Let me make the arrow diagram first, so that it's easier for me to visualize. Right? Now, first of all, let me take the case when 1 is associated with 1. 2 is associated with 1. Now, if I do that, right, this is 1, this is 1, that means f of 3 is fixed to be 3. Right? This cannot go anywhere, it has to go to 3. But 4 has options. Either it can be associated with 1, that will give you one such function. It can be associated with 2, second function. 3, third function, 4, 5, 6. So in total for this I have 6 functions. Cool. Now next one. Now 1, 1. So let me take 1, 2. Right. Now f of 3 is fixed for to be 4. Right. So 2 is associated with 2 and 3 is associated with 4. But 4 again has options. 1, 2, 3, 4, 5, 6. 6 more functions. I can see the pattern now. So if I do 1, 3, so that means I have 5 over here. 6 more functions. Then 1, 4. Then I have 6 over here. 6 more functions. If I take 1, 5, this is 7. 7 is not present over here. That means f of 3 will not be associated. Right? I will not have any element associated with 3. So function is not there. Right? Function is not there. So that means eliminate this case. So where f of 1 is equal to 1, cases have been exhausted. So f of 1 equal to 2. I'll start the chain again. So 1 over here. So that means this is 5. This is 5. That means another 6 cases. 6 functions. Then 2, 2. This is 6. That means 6 more. Mind it, I cannot have 2, 3 option because obviously 3 will not be associated there. Right? So f of 1 equal to 2 exhausted. Let me put f of 1 equal to 3. Right? The minimum I can put over here is 1. Mind it, 7. Right? Cannot be a function. Right. If I move further, 3 will not be associated. That means it will not be a function. So in total, I am getting 36 functions. Option B is the correct one. Alright. The next one. Now he says the coefficient of x raised by 10 in this binomial expansion is this. Right? Where L and K are natural numbers and L is co-prime to 7. Okay. Then K is. First of all, let me talk about the coefficient of x raised by 10 and then I'll compare it with this number. Right? If I want to find the coefficient of x raised by 10, I need to write the general term. Right? General term I know how to write. So that is 60CR into root x raised by, I will obviously separate it out and write it directly. 60 minus r divided by 7 raised by 60 minus r by 4 into, I can say root 7 or I can say 7 raised by r by 2 divided by x raised by r by 3. You can simplify it. Right? I need the terms of x to be together. First of all, let me write it as divided by 2. Then x raised by 60 minus r by 2 minus r by 3. It turns out to be 180 minus 5r by 6. Right? Into 7 raised by whatever it is, we'll try to find out. 7 raised by r by 2 minus 60 minus r by 4. That I have not evaluated. It's okay. Right? Now the thing is, I want x raised by 10, coefficient of x raised by 10, right, 10. So that means this part has to be 10. So 180 minus 5r by 6, that should be equal to 10. This will actually give me r as 24. Right? So this becomes 60C24 into, obviously this will become x raised by 10 and this becomes 7 raised by 3. So coefficient is this one. Right? I need to compare this quantity with, I am erasing this now, I need to compare this quantity with 7 raised by k into L. So L into 7 raised by k. But here's the condition. L, this number is co-prime to 7. That means this number doesn't have any factor of 7 present in it. Right? Now let me see whether this quantity can be L or not. Whether it has a factor of 7 or not. So 60C24 is nothing but 60 factorial divided by 36 factorial into 24 factorial. Right? Cool. We will not panic. It's not that big of a number. So if I cancel 36 factorial, I'll get 37 into 38. So on, I will get into 60. Divide by 1 into 3, 1 into 2 into 3, so on till 24. Right? I'm analyzing this number whether it has a factor of 7 or not. Now 7 factor will be there in the multiple of 7, right? 38, so that means I will have 42 here. I will write only those factors. Then I will have 49. Then I will have 56. Right? Only these ones. And in the denominator, I will have 7. Then I will have 14. Then I will have 21. Rest of them, I don't care. Right? Okay. From here, I can see this is how many factors of 7. So 7 into 6. So I'm just writing the 7 number of factors of 7. So 7. 7 square, okay, and this is 7 again. Divide by 7, just one factor, 7, 7, okay. So 7, 7, 7. Cool. So as you can see, one factor of 7 is still here. So that means this 60C24 is not co-prime to 7. This only factor is there. That means you pick up this factor and you'll put it over here. Right? So whatever the left number is, you can write it down, no need to write it down actually, into 7 raised to power 4 is equal to L into 7 raised to power k. Whose value do you need? The value of k. Obviously that is 4. Alright, on to the next one. Now he says let z be a complex number. If 1 less than mod of z less than 4 and imaginary part of z into real part of z is greater than 0, then area of region determined by all complex numbers z in Argand plane is. So let me study all of this on the Argand plane. Right? Now he says mod of z lies between 1 to 4. Now, let me study what is mod of z equal to 1. All of these complex numbers. Mod of z equal to 4, that means all of these complex numbers. Obviously here origin, like center of both the circle is 0, 0, radius is 1, radius is 4. Now he says all those complex numbers whose distance from 0 is between 1 and 4. So that means all of these. Right? Distance is greater than 1 and less than 4. So that means this region. But he says imaginary part of z into real part of z. Now imaginary part is obviously there on the imaginary axis and real part is obviously there on the real axis. Right? This should be positive. So either both of them is positive, both of them positive, that means this region. Or both of them are negative, so that means this region. I want to find the area of this. This is nothing but half area of the ring. That means half area of ring is pi into 4 square, so 16 pi, minus pi into 1 square, so pi. That is why the answer is D. Alright, the next one. Now he says the line L is given by this and it passes through 8, minus 6. Okay. Then he says line K is parallel to L and has the equation. So line K equation is this one. Then the distance between L and K. Right? Line L is this, so that means here one parameter is there, B. Let me find out the value of B. Now he says that this line passes through 8, minus 6. If the line passes through this, that means this point should satisfy this. So instead of x, I should write 8 and instead of y, I should write minus 6. Just put in and you will get the value of B as 6. So my equation is basically, if I rectify it, 3x plus 2y equal to 12. This is line L. Right? Then he says line K, as in this one, is parallel to L. So that means whatever the slope over here, that is the slope of this line. Here, the slope is minus 3 by 2. That means this one, the slope should be minus 3 by 2. Similarly, you can find the value of C and C will turn out to be 16 by 3. You can put it and get the equation of line as 3x plus 2y equal to 16. This is line K. Right? You need to find the distance between these two lines. Obviously, parallel lines. And coefficients here are same. So you will write mod of C1 minus C2. So that is 16 minus 12, 4 divided by this square plus this square. Obviously, square root. So that is 30. Root 30. Option D. On to the next one. Now he says let F be the set 1, 2, 3, so on till 40. So sum of the elements are first 40 natural numbers. Now he says subset F is said to be nice if sum of its elements is 810. Subset would be nice if sum of all the elements is 810. Mind this is a very big number. Okay. Then he says find the probability that a randomly chosen set is nice. Right? First of all, let me see how many subsets can I have. 40 elements are there, so that means number of subsets would be 2 raised to power 40. Total number of elements, total number of outcomes. Now the favorable one. The randomly chosen set should be nice. And we have already seen that 8 and 10 is a big number. So that means the numbers should be more. Now let me see what is the sum if I add all these 40 elements. So that will be 40 into 41 by 2, that is 820. 810 is very close to 820. So from 820 to 810 if I want to go, I need to subtract 10. That means I can remove those elements whose sum is 10. Right? First, maybe I can just remove one element. One element and the sum should be 10. So obviously, I will remove 10. So my subset would look like 1, 2, so on. Then 9, 10 is not there, so 11. Then so on till 40. First, nice subset. Right? Now, 10 I have written as sum of 10, just one number. I can have 10 as sum of two numbers, so 1, 9. That is the least one. So I will remove 1 and 9 itself. So I will have 2, so on till 8. Then 9 I am removing, 10 and so on till 40. Second nice subset. Right? Then I can do 2, 8, then 3, 7, then 4, 6. Mind it, 5, 5 cannot be done because this is a set. Right? And the next one, this was the 1 element, this is the 2 element, then the 3 elements, 1, 2, 7, 1, 3, 6, 1, 4, 5, 2, 3, 5. Right? These are the only ones. And from each of these, I will get the subset. Then 1 element, 2 element, 3 element, obviously the 4 element, that is 1, 2, 3, 4. Just one I will get from here. In total, how many favorable outcomes? I will get 10 subsets which are nice. That is why option B is the correct one. Alright. On to the next set of questions. Now we are moving on to assertion reason based questions. Right? In these kind of questions, two statements will be given to you. Statement 1, statement 2. Right? Now, statement 1, statement 2. First of all, you will check whether the two statements are true or not. Right? Suppose both of them come out to be true. Then you will check whether the statement 2 correctly explains statement 1 or not. Right? If that is the case, option A is the one that you mark. Right? Second option, what happens when you have to mark option B? Statement 1 is true, statement 2 is true. But statement 2 is not the correct explanation. Then you will mark option B. Right? Then suppose it is the case that statement 1 is true and statement 2 is false. You will mark option C. And suppose it is the case that statement 1 is false and statement 2 is true, then you will mark option D. These instructions are given in the PDF provided in the description box. You can check that out. So without further ado, let me talk about the 15th question. Right? Statement 1, statement 2. What I'll do is, first of all, I'll check whether this statement is true or not. Right? Now here says number of elements in this one. A intersection B union A whole complement. Right? He says that number of elements should be 0. Let me see what this set is. Now here complement is there. So that means first of all I'll apply De Morgan. So that means A intersection as it is. This becomes B complement. Intersection A complement. Right? Okay. Then I would want A and A complements to be close to each other. So commutative property, let me write that as A intersection A complement, intersection B complement. Then associator, A intersection A complement, intersection B complement. Right, number of elements over here. Mind it, A intersection A complement. That is an empty set. Right? Empty set intersection B complement. Empty set intersecting anything will be empty. Right? So number of elements in empty set is what? 0. That means statement 1 is true. Alright. Let me see whether statement 2 is true or not. Now he says A union B. Then he is talking about A intersection B. Then he is talking about A symmetric difference B. Venn diagram. Let me just study the Venn diagram. Right, this is A, this is B. A intersection B is this region and he says it has n elements. And A union B, that means this plus this, that is m. Total number of elements should be m. Then he says A symmetric difference B. What does A symmetric difference B mean? That means this region as in A minus B. Union this region, that is B minus B. Obviously, you can see that these two regions are non-overlapping. Right? Then he says that this united with this will have number of elements m minus n. Obviously, total number of elements were m. Right? N is here, that means rest of the elements will go either here or here. So if I add these two, the sum should be equal to m minus n. That means statement 2 is also true. Now, let me see whether this explains this or not. Statement 2 explaining statement 1. Statement 2 explaining statement 1. Here I am talking about these elements. Here I am applying properties and De Morgan's law. Do you think this explains this? Answer is absolutely not. So both of these are true, but this is not explaining this. That is why option B is the correct one. Alright, the next one. Statement 1. Now he says the largest interval of x for which we can find the sum of infinite GP, which is this one, 1 plus 2x minus 1 plus 2x minus 1 whole square and so on. The largest interval for x for which we can find the sum of this infinite GP is this. So this is the interval of x and he says it should be the largest interval of x. Okay, let me see whether that is true or not. He says that this is a GP. In fact, he says that this is the infinite GP. If I want to add the infinite GP, the terms of infinite GP, the common ratio has a restriction on it. The common ratio, in this case, the common ratio is what? 2x minus 1. The common ratio should lie between minus 1 and 1. Right? This we already know. And this will give me x lying between 0 to 1. You can easily solve it, not a big deal. Right? But mind it, he says that this is an infinite GP. Right? Now, 2x minus 1 whole square, these terms cannot be equal to 0. Because then I am not talking about the GP. In the NCERT book, it is given that GP will be that series where non-zero terms are there. That means this term, and this term, all of these terms cannot be equal to 0. Right? So 2x minus 1 not equal to 0, that means and x should not be equal to 1 by 2. Right? So you can rewrite the interval and it will turn out to be this one. So that means statement 1 is true. Right? Now let me talk about statement 2. He says infinite GP ar square so on can be summed up if and only if the common ratio, the mod of common ratio is less than 1. Mod of common ratio less than 1 means what? Minus 1 less than r less than 1. You already know that. Right? Can be summed up if and only if. That means if it is the infinite GP, then common ratio has to be, mod of common ratio has to be less than 1. And if mod of r is less than 1, then you can sum up the infinite GP. Right? It goes both ways. Now, the thing is, you think, obviously, first of all, statement 2 is true. Next question is whether this explains this or not. Mind it, here what we are doing. We know that in order to find the sum of infinite GP, the common ratio, mod of common ratio has to be less than 1. Are you using that? Right? If it is an infinite GP, the common ratio will satisfy this criteria. Are you using this? Is this given in the statement true? The answer is yes. Because it goes both ways and only if. That means this is correctly explaining this. If this is correctly explaining, option A is the correct one. On to the next one. Now statement 1 is the point on the surface is closest to the line x plus y equal to 3. I want to see whether this point is actually the closest or not. Then only I'll get to know whether the statement is true or false. Right? So let me just tentatively make the rough sketch. So I have, obviously I can rewrite it. I have a horizontal ellipse, something like this. Right? And x plus y equal to 3. My line would be something like this. Obviously it is a little bit exaggerated so that you can actually see what is happening. X plus y equal to 3 and this is my ellipse. Right? Now I want the point on ellipse which is closest to this one. Right? Closest to this one. So that means obviously I'm not looking for this point, this point, this point, this point. No. I'm looking for this point. In fact, can you tell me what happens if I make a tangent over here? It should be valid. Right? That means I want a tangent which is parallel to this one. Right? These two lines should be parallel. Here the slope is what? -1. Here the slope of the tangent should be what? -1. So indirectly, if I want to write the equation of this tangent, that is y is equal to slope is -1. So yeah, slope is -1. So in fact, I can write it like x plus y equal to k. Or you can write y is equal to minus x plus k. Or c, in fact, to be more precise. Because y intercept. Right? Now, the thing is, I need to find out this point. Mind it, I know that this line is tangent to this. That means if I simultaneously solve it, the discriminant should be equal to 0. Right? If I put in that category, that condition, this condition of tangency, I can get the value of C. Right? In fact, C turns out to be, C is plus minus root 6. Right? So basically, my equation of the tangent is either is x plus y equal to root 6 or x plus y equal to minus root 6. Mind it, I know that the y-intercept for this one, right? Those are, that is positive, right? Or if I have the other one, that will be negative. But I want the closest one, so that means I want this tangent. So this cannot be the equation of tangent which I want, right? So that's it. I know the equation of tangent. I know the equation of ellipse. I want to find out this point. Solve them simultaneously and you get the point as this itself. That means yes, this point is actually closest to this line. Cool? So statement 1 is true. Statement 2. He says tangent at this. Okay, that means the point that I found out is perpendicular to this line. Tangent is perpendicular to this line. Obviously, right now we had to put it as the parallel one, right? The tangent is parallel to this line, not perpendicular. So that means statement 2 is what? False. Now, if this is false, that means which option is correct? Option C. Alright, the next one. Now he says given observation x1, x2, so on till xn with x bar as a mean equal to 1 by 3. Now he says statement 1. Let me see. Now he says A is summation xi minus 1 by 2 square. That means each observation, I am taking the difference of each observation from 1 by 2 and I am squaring it up. Right? And then I'm adding them up. So basically, this is nothing but the sum of squared deviations. Right? First one is deviation from 1 by 2. Why? Because difference is deviation. Squaring up, and I'm adding them up. So this is sum of squared deviations. Right? First one is from 1 by 2. Second one is again xi minus 1 by 3. Deviation from 1 by 3. Is mean. Okay, mean. Deviation from mean and squaring it up and adding it up. So sum of squared deviation from mean. Then I have deviation from 1 by 4, squaring it up and adding up. Simple. Again, it is sum of square deviations from 1 by 4. Now he says min, which is obviously minimum of A, B, C. That means this quantity, this quantity, this quantity. He says minimum of these should be equal to C. That means he is saying sum of square deviations from 1 by 4 is minimum. Wait a second. 1 by 2 is here, mean is here, 1 by 4 is here. I know that sum of square deviations from the mean is minimum. That is the property from the mean. Now, 1 by 4 is not the mean. So that means this is not the minimum. And he says this is the minimum. That means statement 1 is false. Right. Let me just read statement 2. It says sum of square of deviations of a set of observations is the least when taken from the mean. True. In fact, that is the property that I used, right? So that means this statement is true. This is false, this is true. That is why the correct option is B. Alright, on to the next one. Now he says statement 1 is this, statement 2 is this. Let me talk about statement 1 first. Right? Now this is summation r weight from 0 to n sine r minus 1 into NCR. Right? Now obviously I will put NCR as n factorial divided by r factorial into n minus r. Right? I need to add up these quantities. I'll write the summation later on. Mind it, I can see two quantities are there, so I will rewrite this as r into n factorial divided by r factorial into n minus r. Factorial minus n factorial by r factorial into n minus r factorial. Right? Summation can be separated out. So r varies from 0 to n, r varies from 0 to n. Right? This is nothing but nc0 plus nc1 plus so on ncn, that is 2 raised by n minus. Here, obviously this will get cancelled with this, so this becomes r minus 1 factorial. Right? R minus 1, n minus r. Ideally, in the numerator, I want n minus 1 factorial. So write n factorial as n into n minus 1 factorial. Don't forget this one. Right? Now, this becomes n minus 1 C0 plus n minus 1 C1 plus so on n minus 1 C n minus 1, which is nothing but 2 raised by n minus 1. And here 10 is. N is in. Right? This is the sum. Let me see whether this is equal to right hand side or not. Of course it is. You can take 2 raised by n minus 1 common and you'll get this. So this is true. Right? Let me talk about statement 2. Now, he says you need to add up all of this. So, let me write the general term. Right? So, NC. Now, mind it 0, 1, 2, so on till n. So, R. So, that means when I'm adding it up, R raised from 0 to n. Cool? Now, here 0, here minus 1. Here 1, here 0. 2, 1. So, that means this thing is nothing but R minus 1. Right? Then, you can see I have x raised power 1 here, x raised power 2 here. So 1, 1, 2, 2. So that means ideally here it should be x raised power 0. So into x raised power r. Right? This sum I just evaluated. Isn't it the same as this one itself? Because then I'll separate it up. Look at this one and look at this one. Right? Again, you can, if you want to write it again, I can separate out the summation. So I will get n minus, so this is r into NCR into x raised power r minus summation NCR into x raised power r. Right? So obviously this becomes 1 plus x raised power n. Right? And this I will cancel out that r, this will become r minus 1. Same thing that I did over here. This becomes n into, I will leave that up to you by the way, n into, in fact, that thing only. N into x into 1 plus x raised power n minus 1. Right? Which is equal to this one. So, this statement is also true. You can evaluate this. I am leaving the calculation to you. Now, let me see whether this explains this or not. Find it, you started out with this, right? This was what? R minus 1 into NCR. Right? This is summation of it. This and this is absolutely same. Why? Because this is same. But then x raised power r. Here you must have put that x equal to 1. You must have put that x equal to 1, right? So that means this sum is equal to this, but x is equal to 1 now. Let's see whether this thing becomes this or not. So x equal to 1, this becomes n into 1. I'm not writing that. 1 plus 1, 2. So 2 raised power n minus 1. Minus 1 plus 1 again, 2 raised power n. In this sum, if I put x equal to 1, this becomes and this becomes, you can see. So that means this is the generalized case. Statement true 2 is a generalized case of statement 1. So that means this will definitely explain this. This is general, this is particular. Definitely explain it. That is why option A is the correct one. Alright, on to the next one. Now he says, if secant square theta is equal to this, is valid. That means this statement is valid. Then x equal to y, where obviously x and y are positive real numbers. He says this statement is valid. Now this statement valid, that means this equation must have some solution. Let me talk about secant square theta on the left hand side. So secant square theta, what can we say about secant square theta? Secant square theta, obviously this was secant theta whole square. I know that this definitely will be greater than equal to 1. Now, if I want this equation to be valid, that means this equation to be true, that means if this is greater than equal to 1, this has to be greater than equal to 1. Then only equality will occur. That means 4xy divided by x plus y whole square should be greater than equal to 1. Alright. Now, you can cross multiply, positive quantities are there, blah, blah, blah. You will get x minus y whole square less than equal to 0. Right, because you'll open it up, 2xy and then minus 4xy, you will get the gist. Right? Now, x minus y whole square less than equal to 0, a squared quantity, it cannot be less than 0. Right? That means it has to be equal to 0. If that is the case, x minus y whole square has to be equal to 0. Only one case. That means x minus y equal to 0. That means x equal to y. if this thing is valid, I have proven that x has to be equal to y, right? That means statement 1 is true. Statement 2. It says cos theta lies between -1 to 1 for all theta. Perfect, that is also true. Learned that in class 10th, I think, or 11th, whatever. Right? Now, I need to explain whether this explains this or not. Here he is talking about cos theta. Right? Here he is talking about secant square theta. First of all, I need to reciprocate cos theta. Right? Reciprocation needs extra steps. Then I need to square it up. Extra steps. So that means this thing is not correctly explaining this. That means option B should be the correct one. Alright, with this we are at the end of discussion of paper number 1. Thank you and I will see you next time.